In this video, I want to give a brief mathematical proof of the rule of 72, which basically allows us to approximate how long it might take for a particular investment to double in value at a certain rate of return. And the idea is that you could do this approximation without having to get out a calculator or create a spreadsheet. You could just do the math in your head. So the basic idea, or the algebra that we need to solve, is that if we had an investment of X, and if that investment was going to earn a rate of return of, say, I on 100, and if that rate of return was going to be earned over n years, then what would the rate of return need to be, or the number of years need to be, to make that investment of X turn into 2X? So that's the basic algebra that we need to solve. And the very first step we can do here is the x's will cancel each other out, so we can drop those off. And essentially we just need to do a bit of simple rearranging to then get to effectively our rule of 72. So the first thing I do here is I take the logarithm of both sides, the natural logarithm. So if we said the log of 1 plus I on 100 to the n was equal to the log of 2, we can then start to bring the n down and make the algebra a bit simpler. So first thing we can do is, if you know your logarithms, you can bring the n down, which would give us n times the log of 1 plus I on 100 is equal to the log 2. And it's at the next step that we start to take what is a mathematical equality and turn it into an approximation. And the idea here is that for in cases where the rate of return I, or I on 100, is small, which it typically is in this case, we're normally dealing with decimals, then there's a truth that says the log of 1 plus I on 100 is approximately equal to I on 100. And based on that truth, we can then replace this log 1 on 100 with just I on 100. And that will give us n times I on 100 is approximately equal to log 2. And you could calculate what log 2 is using your calculator, or if you're like me, you'd probably just know that off the top of your head. And you get to n times I on 100 is approximately 0.693. And then you can simply bring the 100 up and you get n times I is approximately 69.3. And essentially you'd end up with n being approximately 69.3 divided by the rate of return. And that's pretty much it for the algebra. The only final step that most people then do is they'll say, well, 69.3 isn't a particularly helpful number in terms of off the top of your head trying to have divisors, things that can easily divide into that number. So that's how we get the rule of 72. We simply do a fudge and say, well, 72 is pretty close to 69.3. We're already approximating anyway, so why not just shift the dial a little bit and end up with a number that has a lot more divisors? And that's how we get to the rule of 72. And for example, I might say, I bought a property and that property doubled in value over 10 years. So in that case, n would be equal to 10. If that's the case, what's the rate of return? Well, 10 would be approximately 72 divided by I. Doing a simple rearrangement, that would mean I would be approximately 72 divided by 10, which then gets me to about 7.2% per annum. And that's the rule of 72, and that's how we can get pretty good ballpark approximations for rates of return or amount of time it takes if we're looking at an investment doubling in value.